Wilson's theorem based questions are extremely important. Wilson's theorem. Wilson has proposed a theorem based on prime numbers. The theorem goes like this. Reminder, p minus 1 factorial plus 1 when divided by p, it is 0 when p is a prime number. P minus 1 factorial plus 1 when divided by p, reminder it is 0 when p it is a prime number. Extremely important key points. Very, very important key point. Let me take some examples. If p equivalent to 5, this will become 5 minus 1 is 4 factorial plus 1 divided by 5. 4 factorial is 24. 24 plus 1, 25. 25 divided by 5. 25 is perfectly divisible by 5. Reminder it is 0. P minus 1 factorial plus 1 divided by p, it is 0. P minus 1 factorial. Second key point. P factorial plus 1 is not divisible by any natural number. Any natural number from 2 to p. P factorial plus 1 is not divisible by any natural number from 2 to p. Any natural number from 2 to p. It's a very easy explanation. P factorial plus 1 is not divisible by any natural number from 2 to p. Why it is not divisible? Suppose p factorial itself is p into p minus 1 into p minus 2 into and so on up to 3 into 2 into 1. P factorial is divisible by 2, remainder 1. P factorial is divisible by 3, remainder 1. Suppose 17 factorial plus 1 is not divisible by 17 factorial plus 1 is not divisible by 8, 12, 13, 7. E all of this. 17 factorial plus 1 is not divisible by. 17 factorial is the product of all the numbers from 1 to 17. It is divisible by 8, remainder 1. 17 factorial contains 12. Why? Because 17 factorial is the product of all the numbers, natural numbers, from 17 to 1. So 13 is a part of it. 17 it is. It is not divisible by any natural number from 2 to p. P minus 1 factorial plus 1 when divided by p, remainder is 0 when p is prime. One example. Wilson's theorem holds good only when the denominator it is a prime number. Wilson's theorem holds good only when the denominator it is a prime number. Wilson's theorem, Fermat's theorem, all these holds good only when the denominator it is a prime number. Then you can use the other theorems like an Euler's theorem when the denominator it is a composite number. Composite number. Now see here. Concept. What is Wilson's theorem? P minus 1 factorial plus 1. P minus 1 factorial plus 1. When divided by p, it is 0. When p, it is a prime number. When p is a prime number. So only if I take p minus 1 factorial, if I take only p minus 1 factorial, plus 1 goes to the right hand side, it will be minus 1. If you get a negative remainder, add it with the denominator. So answer is p minus 1. Very, very important key point. Extremely important key point. P minus 1 factorial divided by p, remainder is p minus 1. Remainder is p minus 1. P minus 1. From where you got P minus 1? Plus 1, if it goes to the right hand side, it is minus 1. If you get a negative remainder, add it with the denominator. So it is P minus 1. P minus 1 factorial plus 1 when divided by P is 0. Plus 1 goes to the right hand side, it is minus 1. So P minus 1. Very, very important concept, sir. Extremely important concept. P minus 1 factorial divided by P. It is P minus 1. So 17 minus 1. Answer for this question is 16. Answer for this question is 16. We only want P minus 1 factorial by P. Plus 1 goes to the right hand side, minus 1. Negative remainder, minus 1. Positive remainder, P minus 1 it will be. I hope the idea it is clear. 22 factorial by 23. It is 22. Concept is P minus 1 factorial. P minus 1 factorial divided by P, it is P minus 1 when P is prime. It is P minus 1 when P it is prime. We can do, suppose if the question is like this. Remainder 1, 13 factorial divided by 14. 13 factorial divided by 14. We did P minus 1 factorial by P when P is prime. In hurry, don't do. It is composite. 14, it is composite. So 13 factorial can be written as 13 into 12 into 11 into 7 into and so on up to 3 into 2 into 1. 3 into 2 into 1 divided by 14. 3 into 2 into 1 divided by 14. 13 factorial divided by 14. Here 7 is there, here 2 is there. 7 into 2, 14. 14 into any number divided by 14. Answer is 0. Are you all with me? Please do not. Denominator should be a prime number. Denominator should be a prime number. 14. Is 14 a part of 13 factorial? Definitely yes. Here 7 is there, here 2 it is there. Suppose if the question is 23 factorial by 23 factorial by, for example, 77 it is there. 23 factorial by 77. Denominator, it is a composite number. Check it out whether it is a part of the numerator. 23 factorial is 23 into 22 into 11 and so on up to 11 and so on up to 7 and so on up to 1 divided by 77. Divided by 77. 11 sevens are 77. 77 into any number. When you divide by 77, answer 0. Answer 0. I hope the idea it is clear. Suppose if the question is 17 factorial by 32. 17 factorial by 32. What if the denominator it is a composite number and the numerators are factorials? 17 factorial by 32. This can be written as 17 into 16 and so on up to 2 into 1 divided by 32. 16 2s are 32. So answer is 0. Answer for this question is 0. Remainder 1. P minus 1 factorial divided by P. It is P minus 1 only when the denominator it is a prime number. Only when the denominator it is a prime number, you have to use this logic. Now, good question, sir. Listen carefully. Concept. First concept. Remainder when 9 is divided by 2. Remainder when 9 is divided by 2. 2 4s are 8. Positive remainder it is 1. Remainder 1. 18 is divided by 4. 18 it is divided by 4. 4 4s are 16. Positive remainder it is 2. Positive remainder it is 2. What is happening here? 9 and 2 are co-prime to each other. HCF of 9 and 2 it is 1. HCF of 9 and 2 it is 1. Here 18 and 4 are not co-prime to each other. HCF of 18 and 4 both are even numbers. Both are even numbers. Both are even numbers. Not co-prime to each other. So why am I doing this? Wilson's theorem holds that suppose 15 factorial by 17. Don't do it as 15 factorial into 16 divided by 17 into 16. Don't multiply and divide by 16. Don't multiply and divide by 16. Why? Because here 15 factorial by 17, they both are co-prime to each other. Even these is an even number, these is an even number. They are not co-prime to each other. If they are co-prime, I am getting one answer. If they are not co-prime, I am getting a different answer. Don't multiply and divide and make them not co-prime to each other. As it is, whatever the question is there. As it is, whatever the question is there. With the same thing, we will solve it. Don't try to make them non-co-prime to each other. I hope the idea it is clear. Don't try to make them non-co-prime to each other. Second concept. Second one. 9 into 7 by 2. 9 into 7 by 2. Now see here. If it is 9 into 7 by 2, 9 divided by 2. 2 4s are 8, remainder 1. 2 3s are 6, remainder 1. As long as the numerator is less than the denominator, here the numerator is less than the denominator. As long as the numerator is less than the denominator, how many times you divide, it does not matter. 2 4s are 8, remainder 1. 2 3s are 6, remainder 1. 1 divided by 2, numerator it is less than the denominator. Even if you further divide by 2, answer will not change. As long as the numerator value is less than the denominator, remainder does not change. Remainder does not change. Now see this. Listen carefully to this 27th question. 27th question. Very, very good question, sir. Wilson's theorem, foundation problems and advanced level problems will solve. In the previous concept, we discussed 16 factorial by 17. 16 factorial by 17. P minus 1 factorial by P. P minus 1 factorial by P is P minus 1. P minus 1 factorial by P, it is P minus 1. 16 factorial can be written as 16 into 15 factorial by 17. It is 16. 16 factorial is 16 into 15 factorial. N factorial can be written as n into n minus 1 factorial. 16 factorial is 16 into 15 factorial divided by 17. I hope it is clear. 16 divided by 17. 16 is less than 17. So 16. 15 factorial by 17. This remainder I need to find it out. X is nothing but remainder when you divide a number by 15 factorial by 17. X is termed as remainder when 15 factorial divided by 17. When I further divide, if the numerator is less than the denominator, answer will not change. Just by looking at a question, I can tell that the answer is 1. 16 ones are 16. 16 by 17, it is 16. From this step to this step, it should be absolute clarity, sir. 17 zeros are 0. 16. 15 factorial by 17. We want the remainder for this. We do not know the remainder. Let me call it as x. If the numerator value is less than the denominator, if the numerator value is less than the denominator, answer does not change. So x is termed as 1. X is termed as 1. 16 ones are 16. 16 ones are 16. I hope the idea it is clear. Similarly, one more question we will solve, then we will do the next method. Just give me 1 minute, sir. I'll just have a glass of water. I hope the idea is clear. Try to solve this question. What is the answer for this question? Are you getting 1? So everything is going properly. I just checked in my mobile. Are there any issues? 17 factorial divided by 19. Now see here. Reminder. 18 factorial. P minus 1 factorial by P. It is P minus 1. 18 factorial by 19. It is 18. Now see here. Same thing. N factorial is n into n minus 1 factorial. N factorial it is defined as n into n minus 1 factorial. So 18 factorial is defined as 18 into 17 factorial divided by 19, it is 80. 18 into 17 factorial divided by 19, it is 18. Same thing. 19 zeros are 0. Remainder 18. 17 factorial by 19. We do not know. When I further divide, I am getting the answer 18. Here also I am getting, just by looking at a question, 18 ones are 18. 18 by 19, it is termed as 18. X is 1. Is it always 1? Yes, it is always 1. When the denominator, it is a prime number. Remainder 1. P minus 2 factorial. Remainder 1. P minus 2 factorial divided by P, it is 1. If P is a prime number. If P is a prime number. Very, very important concept. We did it for P minus 1 factorial by P. Now it is P minus 2 factorial by P. Reminder 1. P minus 2 factorial by P. It is 1 as long as P is a prime number. As long as P is a prime number. If the question is 35 factorial by 37. Reminder it is 1. Reminder 1. 21 factorial by 23. Reminder it is 1. Reminder 1. 69 factorial by 71. 69 factorial by 71. It is also 1. P minus 1 factorial when divided by P. The answer is P minus 1. P minus 2 factorial when divided by P, answer is always 1. One term we went backwards, now we went 2 terms backwards. Very, very important logic. P minus 2 factorial divided by P, it is 1. From here, some very, very good questions can be developed. Now see here. Let me solve this question. Reminder, please put a star mark, sir. Reminder, 8 factorial whole square. Just now we discussed 15 factorial divided by 17. It is 1. Reminder, 15 factorial when divided by 17. It is 1. We require 8 factorial, right? So let me write down like this. 1 into 2 into and so on up to 8. 9 into 10 into 11 into 12 into 13 into 14 into 15 divided by 17. It is 1. We require 8 factorial whole square. We know that 15 factorial divided by 17, it is 1. 1 into 2 into 3 till 8. Product of all the natural numbers from 1 to 8, it is 8 factorial. Are you all with me? 8 factorial is product of all the natural numbers from 1 to 8. 9 divided by 17. 17 ones are 17 minus 8, negative remainder. 17 ones are 17 minus 7 minus 6 minus 5. 15 divided by 17 minus 2 divided by 17, it is 1. I hope it is clear. Only the first part of it I am taking it. Next part I am doing negative remainder. 17 ones are 17 minus 8. 17 ones are 17 minus 7. 17 ones are 17 minus 6 minus 5. Now see here. Listen carefully. Just a question twisted. 2 to 8. 2 to 8. There are 7 negatives are there. 2 to 8. There are 7 negatives are there. 8 factorial into 7 negatives, it is negative, minus 2 into 3 till 8 divided by 17, it is 1. Minus out 2 into 3 into and so on up to 8 is 8 factorial. Whole square divided by 17, it is 1. So this will be 8 factorial whole square divided by 17 is minus 1. Negative remainder minus 1. Positive remainder 16. Very, very good question. Instead of asking p minus 2 factorial by p, he is trying to give a derived version of p minus 2 factorial by p. 15 factorial by 17, it is 1. 1 into 2 into 3 till 8. 9, 10, 11, 12 till 15. 1 into 8 is 8 factorial. 17 ones are 17 minus 8 minus 7 minus 6 minus 2. 2 to 8, there are 7 negatives are there. 7 negatives, so minus came. 2 into 8 is 8 factorial. Minus multiply negative remainder minus 1. Positive remainder 16. Negative remainder minus 1. Positive remainder 16. I hope this question is clear. This is derived from this question. I think one more question is there. Each and every question, sit when, in case if you are watching the class right now, ensure that you prepare your own handwritten class notes and solve it along with me. Solve it along with me. 35, another question. 35 factorial whole square. 35 factorial whole square divided by 71. So if I use p minus 2 factorial, 69 factorial by 71, it is 1. 69 factorial by 71. 69 factorial can be written as 1 into 2 into 3 till 35, 36, 37 and so on up to 69 divided by 71. Divided by 71, it is 1. Divided by 71, it is 1. 69 factorial is 1 into 2 into 3 till 35, 36, 37 till 69. 1 into 2 into 3 till 35. Product of all the natural numbers from 1 to 35. 35 factorial. 36 by 71. 71 ones are 71. Minus 35. Next one it is minus 34. 71 by 71 ones are 71. Minus 2 divided by 71. Divided by 71. 2 to 35. 2 to 35. There are 34 negatives are there. 34 negatives, if I multiply, I will get a positive. So 35 factorial into 35 factorial divided by 71, it is 1. So answer for this question is 35 factorial whole square divided by 71, it is 1. Please make a note of it. 35 factorial whole square divided by 71, it is 1. 69 factorial divided by 71, it is 1. 69 factorial is 1 into 2 into 3 till 69. First part of it, it is a factorial. 1 into 2 into 3 till 35. 35 factorial. Minus 35, minus 34, minus 2. 2 to 34, total 34 negatives are there. So if I product it, I will get plus 35 factorial into 35 factorial by 71, it is 1. 35 factorial whole square divided by 71, it is 1. I hope the idea it is clear. P minus 2 factorial.